Somebody said yes. I'm assuming that's to the triangle. All right. So the limiting factor for one of the limiting factors for batteries is the competition between discharge and charge rate, cathode thickness, and cell volume. You can't do all of those things at the same time. If you crank the discharge and charge rate up too high, it creates too much heat. If you make the cathode too thick, it creates too much heat. And if you create a cell that's too large, that creates too much heat. Of course, discharge and charge rate, those are positives. The reason why you'd want to have a thick cathode is because if you just increase the cathode thickness by 25%, you get about a 10% specific energy increase. So that would be going from like 300 to 330 watt hours a kg. Cell volume, if you just increase the cell volume by a small amount, say when Tesla went from 18,650 to 2170, that small increase reduced the number of cells they needed to create by about 30%. And we have 30% less cells, you have 30% fewer welds, 30% fewer separators, 30% fewer cell cans. It's just, it makes it a lot cheaper and easier to manufacture the battery pack. Now, I said that there was two ways to shrink the triangle to try to fix all these things at once. The first was for Maxwell's dry cell technology, and what that does is it uses a lot less additive material, and because the additive material isn't being corroded by the liquid solvent, it has much lower resistance. And because it has much lower resistance, electrons can get in and out of the cell much more quickly, and there's less heat and less resistance. There's one way to combat it, and the other way to combat it is to improve the thermal management system of the battery. So with all that, and that's our problem that we're trying to solve. All right, so this is my model for a current battery cell. I've used a toilet paper roll. This is the cell can. I'm just going to take the cell can and throw it away. And currently, what happens is, in order for the, I'll just move this around here. In order for the electrons to get in and out of the battery cell, they have to go through one of these little tabs. And that's a huge ass bottleneck. If you're an electron and you're in the center of this toilet paper roll, you have to go through that maze, all those different spirals to get out of the battery, or in this case, our toilet paper roll. And then when you get there, there's a big bottleneck in the form of these tabs. Well, what Tesla's decided to do is the best part is no part. So they just get rid of these. Now, how is this cathode or anode material, how's it going to get to the collector and get to the edge of the battery if you don't have those tabs? Oh, first off, you can see that the black goes pretty much all the way to the edge here. That's the cathode material. What they've done is they create an offset at the top of the battery cell. So all you have to do is just put some conductive adhesive on the top of the bottom, jam it in the cell, boom, all the electrons can access from any point, from any layer. And you don't have to fiddle around with that stupid little tab and weld those fickle little pieces of metal to each other. So A, that makes the manufacturing a lot easier. And B, if you're an electron trying to get through all that mess and all that maze, you're bumping into a lot fewer other pieces of material. And if you're bumping into fewer pieces of material, it's creating less heat because there's less friction. So that adds a way that we can solve our triangle problem. So with that in mind, I hope that explanation made sense. I haven't had a chance to read all the comments yet. Anyhow, I'll start reading these comments. The implications of this. I haven't had a chance to sit down and process this, but it looks like what this means is Tesla should be able to greatly simplify the manufacturing process by making the cells smaller, by making the cells bigger. So they need fewer cell cans, fewer tabs, less tab welding, fewer separators. It's just all of a sudden the amount of the number of pieces of each material they need to create these battery cells and battery packs could be cut by 30, 50, maybe even like 70%, depending on how big they make those battery cells, how big they make the diameter. Because the rumors I've heard are 40 millimeters. I don't know if that's correct or not, but this makes it much more likely. It makes that rumor from a possibility to, oh yeah, this is a pretty good chance that they're going to increase the diameter of the cell. Now, what it also does is it allows for increased discharge and charge rates because there's less heat generated by that. People say they look like little silver beer cans. What else? Charge, discharge rate, energy capacity. Yeah, increased energy capacity because whenever you have a battery cell, if you keep that can thickness the same and you increase the internal volume, the proportion of this paper to, metal or paper, the proportion decreases as the cell gets bigger, so you get more energy capacity per given volume. So you should be able to increase the energy density and potentially increase the cathode thickness. If they can even increase the cathode thickness by like 10%, that's, they'd be getting another 3, 4, 5% specific energy capacity. I mean, this is really cool. I was hoping that Tesla would unleash something straight out of left field that I hadn't anticipated. And this is it. This is awesome. Let me read these comments again. Tesla will use toilet rolls for the new battery cells. Thanks, Lars. So previously when people asked me if Tesla would be able to shorten charging time with this new cell chemistry, my answer was, well, it depends on how they engineer it. Well, it still depends on how they engineer those battery cells, but it makes it much more likely that they can do the energy capacity, discharge and charge rate, and simplify manufacturing, do all of those instead of just one or two of them. No, I haven't heard any updates, Perry, on any updates when or if Battery Day is still this month. I haven't heard anything to the contrary. The cell voltage, I'm expecting 4.3 volts because that's all of Jeff Dahn's research was done at 4.3 volts. If I get a chance before Battery Day, I'd love to make a more in-depth video instead of using toilet paper rolls. So, but I'm just, after the Hyperchange interview, I have a number of people asking me for interviews. In fact, I'm going to have another one with EV Stock Channel here in a couple hours. So I'm busy. And then on top of that, I have work. So... Oh, the battery will still need cooling. But this reduces the engineering demands on the cooling side of things. How many gigawatt hours for pilot cell line annually? Ooh, that's a good question. It depends on if the pilot cell line that they're building in Fremont, if they're building it in Fremont, if it's, I'm assuming it's just for the Plaid Model S, but I think those batteries are going to be used for something. And I think they're going to validate the cost model with the S and the X. Now, I theorize that it would be 5 gigawatt hours for the pilot line, based on the research I've seen. Thanks again, SMO. I'll answer your question in a second. But at a very minimum, it's going to be at least as much as Panasonic's lines, which I think is about 3 gigawatt hours. But the thing is, people are saying that this could go up to 10 to 16x what a current cell line is. So that would be 30 to 45, yeah, something 30 to 40 gigawatt hours is the potential for one line. Now, I think that's absolutely insane. I'm not in that camp, but I would say it would be, if you're going to do a terafactory, I think you're going to need lines that are at least cranking out, 10, 15 gigawatt hours. You'd also have some space savings there, so that would factor into the mix. And it looks like Tesla's factories are getting bigger. There's really no way to know. But yeah, I'd like to see a minimum of 5. 10 would be great. Anything above 10 is absolutely, that's in the stratosphere. And yeah, goodbye every other auto OEM. Tesla is talking about 250 kilowatt hour charging for Model 3. How fast could we go with these new packs? Any speculative predictions? Well, all right, sweet. Here we go. So this is a dry-coated electrode or dry-coated cathode versus a wet-coated cathode. Now, a 0.1 discharge rate is like, that means charging or discharging in 10 hours. So that's really slow. And 0.2 is charging or discharging in 5 hours. 0.5 is discharging or charging in 2 hours. And this is where you see a massive difference between the dry-coated cathode and the wet-coated cathode. You can see that for if you charge or discharge within an hour, the dry-coated cathode retains much more of its capacity. Basically, the wet cell, as you start draining it or charging it, it heats up. You get a lot more internal resistance, and the capacity at that point is reduced considerably. And it looks like by about 30%. What is here? 50 versus 90. It's about 40% difference, or 30% difference at least. So I imagine that continues to get even steeper as you move towards, like a half-hour charging time. So I would think you'd be able to double the charging time. It really depends on how they engineer these cells. And it's also dependent on how much power that those superchargers can put out. I would think that with this Maxwell dry electrode technology, as well as this new tab technology that allows the energy to get in and out of the battery cell more quickly, that you'd be able to at least double the speed that you get the electrons in and out of the cell. There might be another factor there that I'm not aware of, but yeah, I think it would max out the current V3 supercharger, and you might need a V4 supercharger to fully take advantage of it. Yeah, absolutely. Tesla is definitely with this. I mean, it looks like Tesla has been incubating half a dozen or a dozen technologies over the past decade. And I think they knew well before they acquired Maxwell that they were going to start building their own cells. And they've been engineering this stuff, waiting for everything to come together. And now that all the pieces have come together, they're going to implement technology which is not just slightly better, but a revolutionary change. In the negotiations when Tesla was trying to take over Maxwell, they said, hey, if you guys don't jump on this, we're going to go do our own thing. I think Tesla had an internal timeline for when they wanted to do their own batteries, and Maxwell is icing on the cake. But I think when they were in those negotiations, they were being honest. I think Tesla had, we have 4, 5, or 6 innovations in our, little treasure chest of innovations. And even if we don't go with Maxwell, it will still make us the leaders in the industry. And so I don't think they were bluffing during those negotiations. I hope that answers your question. I think it was just a stroke of luck that Maxwell managed to get their technology working at the same time. And Tesla would have seen the Maxwell technology coming for probably 5, 6, 7 years, because all of them are on a board called the Battery 500 Consortium, and J.B. Straubel's on that, and he would have been monitoring Maxwell technology to see how their technology is developing. Yeah, we're talking about a Tony Stark change. All right. So many good questions here. Mega How To Man asks, are they going to put Panasonic out of business? No, I don't think so, because my view is, as long as your batteries are better than fossil fuels, then you don't have any competition for a good decade from now. It doesn't matter if Tesla's technology is 5 or 10 years ahead of everybody else. What battery makers are competing with is the fossil fuel industry. And as long as they can provide a better alternative to that, then I think they'll continue to thrive for the next decade. After 10 years or so, then I think there'll be some competition in the market because there'll be less market share. Okay. Yeah, I'm tempted to buy more stock too. I probably should have mentioned this in this videos. I don't know if it's relevant or not. My focus is mainly on technology, so I don't think I need to let everybody know what investments I've made. But I started investing back in 2016. There was an interview with an analyst named Andrea James, and to this day, I still think she's the best analyst that was ever on Tesla. And she was interviewed by Dave Lee on investing. I think it was like August 9, 2016, something like that. The next day after watching that interview, I bought my first shares of Tesla stock. The reason for that is because she said she got a tour of Level 2, and she said the things that they were doing on Level 2 in Tesla and their secret skunk works were so amazing that it almost made her cry. That's how amazing they were. So I bought stock the next day. I continued to buy stock all the way through the dips last year. And it's tempting to buy more at these prices, but I think the market's going to take a hammering. But I have confidence in Tesla. Battery players. I'll just read this out. I know you're curious about the smaller battery players. Have you tried buying Nano One stock? It looks to be fairly illiquid. I haven't tried buying Nano One stock because I haven't been convinced that they actually have a customer yet. I'm confident in their technology. I think what they're peddling seems like a good product, but there's a lot of people peddling that product. CATL has fully commercialized single crystal cathodes in China. They're way ahead of us, way ahead of the Western world in that respect. But I think what Tesla's bringing to market is going to shock the world, at least shock the people in the world that care and know the significance.